Students quite often learn about branching databases when they're at primary school, and branching databases are effectively a binary tree, but then somehow we forget about those until we get to A level and we look at things like reverse Polish notation and linked lists. So I quite like this exercise from the OCR Coding Challenges for GCSE computer science students, because it reminds us of branching databases, but it also helps us to think ahead and how we'd actually implement that binary tree. And there's a simpler way we can do this. There's a slight complication if you do it in Python, but we'll come to that towards the end of the video. So there's two things you need to think about. Firstly, how you're going to organize the data, and then secondly, how you're actually going to code it. So in the question, it asks you to differentiate between these different animals, but it also suggests you might do it with a pot band. So I'm going to do a simpler version, using the Beatles as an example, and in the description of the video I will put a link to this document and also a link to my proposed solution. Obviously there might be other ways to do this, which does include the animals. So what we're going to think about is how we're going to organise this information. So I'm going to use the Beatles as an example, just so there's less typing for you to watch in the video. So if you're not familiar with the Beatles, there were 4 members. There was the drummer, Ringo, there was the bass player, Paul, and there were 2 members who played the guitar, so that's John Lennon and George Harrison. And certainly later on, John wore glasses, so that's how we're going to differentiate them. So this is very much like prime factors in maths. So there might be, if you use prime factor trees to find the prime factors of a number, there'll be multiple trees depending on which factors you picked to begin with. So if you're factorising 56, for example, you might do 2 lots of 28, or you might do 7 eighths, and it doesn't matter which way you go, but you get a different shaped tree. And you can do the same thing with branching databases. So if our first question was, for example, is this member the drummer? Okay, so if we say yes, so we go left for yes. So if it's yes, then it's Ringo. Okay, but if it's no, then we need to ask another question, don't we? So what other question could we ask? So we could say, do they play the guitar? And if the answer is no, then it's Paul, because he played the bass. And if it's yes, then we need to ask another question. So we need to ask whether whether they wore glasses. And if it's yes, it's John. And if it's no, then it's George. So that's fine, that would work. But if you look at the number of questions that you would ask, so to work out whether it's Ringo, that would be 1. For Paul, you need to ask 2 questions, and for each of those, John and George, you would ask 3 questions. So that's 6, 7, 8, 9, 10. So that's 9. So an average of over 2 questions per person. So there's also an implementational kind of issue, but we'll come to that later. It depends on how you actually store this tree. So if we just back that up a little bit, another way to do it would be to ask a different question first. So if we asked whether they played the guitar first, then if it was yes, then obviously that narrows it down to either John or George, and then we could ask whether they wore glasses, and if it's yes, then it's John, and if it's no, then it's George. And then we could ask a different question here, so we could ask the same question as we had on the left, but so drummer, yes, Ringo, and no, Paul. So we've got a different shaped tree. It's more balanced, so it's more symmetrical. And if you look at the number of questions we need to ask for each person, we need to ask 2 to find out whether it's John, 2 for George, 2 for Ringo, and 2 for Paul. So slightly fewer questions overall. So you could say this is a more efficient way. But also when we come to organise this, when we come to save this, then this will give us a slightly neater solution as well, I think. So let's go with the one on the right. So what I did, when I did this with animals, I had to think about, it doesn't mention the questions that you could ask, or certainly doesn't mention all of the questions. So I tried to pick a question that would kind of split the animals in 2, and at each stage I tried to think of a question that would split the animals into 2. So you could include links here to things like binary search and how that's the more efficient way to do it. So with the animals, I think the first question I asked was, is it a mammal? Because about half of them were mammals and half of them weren't. And then you've also got things like, so there was both an octopus and a spider. So you could think of questions where you try and get more than one answer. So in my example on the left there, is it a drummer as the first question? There's only one answer. You could also, if you're doing the AQA, I suppose you could link it into Huffman coding. And the length of the trees and the branches and the efficiency of the coding, etc. Okay, so what we're going to do, so now we're going to have a look at how we'd actually store that information. So we're moving on to the implementation now. So if you're doing this at A level or at university, you'd probably be looking at linked lists or something like that. But actually, you can store a binary tree in an array. So and if we look at how this might be stored, so if we look at element 1, so the question would be, is it guitar? And in fact, let's go down rather than across, so is it a guitar? So that's element 1, and let's go, so left branch, so we look at, if this is n, the position in the array, and we'll say left branch goes to 2n, so left goes to 2n, and right goes to 2n plus 1. So if we say yes, that'll take us to item 2. Item 2 is the question, isn't it? Is it glasses? And so the right branch from the guitar, 2n plus 1, so that takes us to item 3, is the question, is it a drummer? So we'll put a question mark to indicate that these are questions. And then, so item 2, so that's the glasses. So the left branch takes us to 2n, so that's item 4, and that will be John. 2n plus 1 is 5, so that will be George. And then the drummer question, so drummer is item 3, the left branch is 2n, so that will be 6, will be Ringo. And 7 will be Paul. So that's how we can arrange a binary tree into an array. So if we had a more kind of lopsided tree, what you'd get is empty elements in there. And empty elements wouldn't matter, but obviously you'd have a longer array overall. It wouldn't matter if they were empty because you just jump over them. It's a little bit more tricky with Python because obviously Python doesn't have arrays, it has lists, so you can't have empty items in a list, so we need to have some way of padding it out, which we'll have a look at in a minute. So that's how we're going to store this. The only other thing we need to think about is how we decide when to stop. So if we want to kind of generalize our program, then we're going to keep going until we arrive at an answer. So John, George, Ringo and Paul are answers. They're effectively the leaf of the tree. Guitar, glasses and drummer are the kind of questions, if you like. They've got children. So we need some way within the code to differentiate those. So we could look at the question mark. What I did in my example program is I had a Q as the first letter of the question and an A as the first letter of the answer, but you could have R for responses if you're not thinking of it as an answer. So let's have a look at how we can implement that. So the first thing we need to do is we need to have our tree. So if you just go to Python here, and so tree, and so we could use, it doesn't matter whether we use a list or a tuple for this, but actually I'm going to, probably there are some benefits in using a tuple. I think there's some performance benefits, but and we're not going to change it, are we? But I think people tend to be more familiar with lists, so I'll just go for list here. So We always start at 1 because for this method to work, obviously we can't start at item 0 because 2 lots of 0 are still 0, so we wouldn't be moving on. The first item would refer to itself. So I'm just going to put a 0 in there. In fact, what I'm going to do is I'm just going to, because we need to, there aren't any empty ones, empty items in this, but unless you've got a kind of perfectly symmetrical tree, you are going to have empty items in your array. So what I'm going to do to begin with, just as kind of placeholders, I'm just going to put indexes in there, and I can use those to pad out any null items if I was, if I didn't have a symmetrical tree. Okay, so now I'm going to swap these with the items that I've actually got. So 1, 2, and 3 are guitar, glasses, and drummer. So swap those for the strings. Guitar, glasses, and drummer. And then we've got John, George, Ringo, and Paul. So, oops. So John, George, Ringo, and Paul. So that's my data, that's my tree set up. I suppose if it's a big tree, you could read it in from a file or something like that. And the other thing we need to do is we need to differentiate between questions and answers. So you could look at the question mark on the end, but I'll do it the same as my example. So I'm going to put a Q at the start of the question. So those 3 are questions. And then these 3, actually it doesn't actually matter what I put at the start of those 3, but I need something just to differentiate them. So what we're going to do is we're going to have our current node, and we're going to start at 1, and then we're going to say, I'm going to use that as an index into the tree. So I'm going to say while tree current, so that'll be, so in this case it'll be looking at the first question, and then I'm going to say, so while that the first character is not Q, no, well it is Q, sorry. We're going to repeat until it's not Q. What are we going to do? So we're going to print that question. So obviously in the actual task you could print a longer question. I'm just trying to stop it getting too wide and going off the screen there. So what I'm going to do is I'm going to say answer equals input, and then I'm going to use that question. I'm actually going to print that question, but obviously I just want it from 1 onwards. I don't want the Q, do I? And then what I'm going to do is, just to make the answer a bit more easier to process, I'm going to force it to lowercase, and then I just need to check for 1. Why don't I? In fact, what I'm going to do is I'm going to just make it a little bit clearer. So I'm going to put, I'm going to say YN. There. Okay, so then I'm going to say if answer is Y, so we force it to lowercase, it's definitely going to be. Then we're going to say, so if it's yes, then we're going to go to the left branch. So we're going to say current equals current times 2. So I could have used times equals 2 in Python there. Otherwise, so I'm not going to check for now, I'm just going to check it's not yes. Current equals current times 2 plus 1. Don't need any brackets in there because of bid mass, etc. Okay, so what we're doing is we're repeatedly asking questions. If the answer is yes, we're going to go the left branch, which is twice the index. Otherwise, we're going to go the right branch. And then if it's not, it doesn't begin with Q, then it's just the answer, isn't it? So then we're going to print the answer. So again, it's that. But ignoring the first character. So hopefully that should do it. So if we run that, we've got an error, unexpected indent. Okay, yeah, fair enough. So do they play the guitar? Well, let's think of our test case first. So let's pick Paul McCartney. Okay, does he play the guitar? No. Is he the drummer? No. Then it's Paul McCartney. Yeah, so that's worked, doesn't it? So if we have a look, so let's pick Ringo Starr. So does he play the guitar? No. Is he the drummer? Yes. It's Ringo. Okay. So we're just doing a test case for each of the members. So let's go for John Lennon. Does he play the guitar? Yes, he does. Has he got glasses? Yes, he does. And then we'll try George. So does he play the guitar? Yes. Has he got glasses? No. And that's George. Okay, so obviously you could tidy this up a little bit. You could put I like a space in there, so I would. That's quite easy to do, isn't it? So I don't like my answer to appear immediately after the question. So we could do that, and then obviously you could make the questions a bit more verbose and have a little bit more text in the end. But that's basically the thing. So it looks like. To begin with, when you look at the question, it might be quite a complex code. So it says, is there a better way to do it using 101? Well, it wouldn't be literally 101, I think, with that many animals. But a shed load of if then else's. Well, you could do it with that. You could say if. But then you'd probably have to nest them all, and it'd get quite complicated. So quite often, thinking of some sort of structure to help you with the logic. Is a good way to go. You can also do this with things like if you're doing rock, paper, scissors. So rather than saying if it's rock and the computer picked paper, or if it's rock and the computer picked stone, and structuring it that way, you could use a two-dimensional array and have a lookup table with comparing combinations of the two players' choices. So thinking of a kind of some sort of diagram or some sort of logical structure can help you, and then you need to think about how you're going to code it. So in this case, we've turned our binary tree into an array. So if we have a look at my actual animal one, obviously let's see if we just zoom out slightly. Obviously the tree is much bigger to start with, and because it's not perfectly symmetrical, what happens towards the end? If the left-hand side of the tree is shorter than the right-hand side, then we're going to have some null elements. So that's where I've put numbers in to indicate the index, because you can't have nothing in a list in Python. You could do in an array in, say, Visual Basic or possibly C or something like that. So there are some numbers in here to indicate basically empty sessions. That's where the tree finishes. So there's quite a lot of numbers there because one side of the tree is longer than the other side. But other than that, my finished animal one is basically the same. It's longer because it's got comments in it, but and it's got a few more niceties at the start, but it's basically the same. So actually, 9 lines of code, job done.